Hi there, it's the Math Dog. This is a video in a series that I'm doing on trigonometry. So this is a trig identity video, and I'm going to show in this video how the cosine of a minus b is equal to the cosine a of a times cosine b plus sine of a times sine of b. I'm cutting the restriction here, so this video may be shared with others. So let's get started here. So a couple things I'm going to recall. First of all, the distance formula. If you have 2 points in the xy coordinate system, so this is the y-axis, x-axis, let's call this point having coordinates x sub 1, y sub 1. This point has coordinates x sub 2, y sub 2. So I've drawn a right triangle under these. I'm trying to find the length of this segment. I'm calling it D. I'm going to draw a right triangle under D. So now I can use the Pythagorean Theorem. So notice that this is going to be, I'll just call it the absolute value of x sub 1 minus x sub 2. Really don't even have to do that, but when I square it, I'm going to get x sub 1, the quantity x sub 1 minus x sub 2 squared. And actually that is wrong. This should be over here. That's the y coordinate. So let's start with x over here. So this is going to be absolute value of x sub 1 minus x sub 2. This is going to be the absolute value of y sub 1 minus y sub 2. I'm just keeping it positive. Actually, when you square it, it's always going to be positive. So when I square these by the Pythagorean theorem, I get this leg squared plus leg squared is hypotenuse squared. So the quantity x sub 1 minus x sub 2 squared plus quantity y sub 1 minus y sub 2 squared is d squared. Take the square root of both sides, you get this. This is your distance formula. I'll be using that in just a moment in my derivation of the formula that we're doing of cosine a minus b. Okay, then also recall on the unit circle. Unit circle has radius 1. So if I draw a right triangle here, I'll call this x, this y, this is 1. So notice using this is going to be my angle theta. Again, this is radius 1. Notice that cosine theta, cosine, remember, from SOHCAHTOA, is adjacent hypotenuse. So the adjacent side here is x, the hypotenuse is 1, so cosine theta is x over 1, so cross multiplying or just getting rid of the 1, x is cosine theta. So then sine is opposite over hypotenuse. So sine theta is y over 1, which is y equals sine theta. So every point on this unit circle can be expressed, instead of saying xy, we could also say xy here. But that's going to equal cosine theta sine theta. So every point on this unit circle can be described using the coordinates cosine theta sine theta. We're going to need that in the proof that follows in just a second here. Alright, so I'm going to show that cosine of a minus b equals cosine a times cosine b plus sine a times sine b. So I've constructed 2 unit circles here. Let's look at the first one. So again, it's radius 1, that's the point 1, 0. I've constructed a line segment here, let's call the center circle, let's give it a name, let's just call it, I think I can call it O. Okay, this is OB, OA. And then I've constructed a segment AB. So I'm going to call this angle here, starting from right here, the point 1, 0, this is going to be 0 degrees or 0 radians. We'll use, doesn't matter here right now. So I'm going to call this angle A from here, to this segment OA. I'm going to call this angle B from here to this segment OB. And then the difference between angle A and angle B, I'm going to call theta, the Greek letter theta. So it's not a, this is just a sketch, but these 2 triangles are supposed to be congruent. So I construct a congruent triangle here. Well, before I go there, let's look at this. So I have points A and B. I'm calling this then, by what I talked about just a moment ago right here with this, how I can name points on the unit circle. This is good. This corresponds to angle B. So this is cosine B, sine B, this point B. And point A down here is cosine A, sine A. Okay? Now over here, as I was saying, I constructed a congruent triangle to this triangle right here. This is my angle theta. I'm starting this triangle with one of the sides being right on the pointing directly east here at 0 degrees. So then I construct an angle theta, which the way I've drawn it goes in the second quadrant. I'm going to call this point C, and it has coordinates, because this is angle theta, has coordinates cosine theta, sine theta. So again, these are two congruent triangles. So particularly what I'm concerned about here is, well, we know these two sides are what I'm really interested in. They're going to be congruent. So I can now say from the diagram that the quantity AB squared, or the segment AB squared, the length of segment AB squared, I should say, is equal to the length of segment CD quantity squared. So from that, now we will use our Pythagorean Theorem distance formula. So AB squared is going to be the quantity cosine A minus cosine B quantity squared plus, plus then sine A minus sine B quantity squared. And this is your distance formula here again. So I'm taking the difference here. This is like x sub 1 minus, or I'm doing it this way, x sub 1 minus x sub 2 quantity squared plus y sub 1 minus y sub 2 quantity squared. And that's going to equal then this, which CD quantity squared, I'm going to take this time to go this way. You can go either way. You're going to square it. It's not going to make any difference in the end. But I'm going to go cosine theta minus 1 quantity squared. That's like x, this is like x sub 1 minus x sub 2 quantity squared plus sine theta minus 0. Well, minus 0, I don't need to put that in there. So this is plus sine theta quantity squared. Okay, now I need to multiply this out. So this is going to be cosine squared A. So what I'm doing is a binomial squared. So I square cosine squared A minus double the product here, which is going to be minus 2 cosine A cosine B plus cosine squared B. So that takes care of this. Plus, then I have to do that for this also. This is going to be sine squared A minus double the product here. That's minus 2 sine A sine A sine B plus, then I have to square this. So that's plus sine squared B. Okay, and that's all this multiplied out. Now this is going to be a binomial squared. This is going to be equal to here cosine squared theta minus double the product here, 2 cosine theta plus 1 squared is 1 plus sine squared theta. Okay, there's another important property that I failed to put in the previous page, so I'm going to go back and do that now. So notice from the Pythagorean theorem in this right triangle that I formed on that unit circle that we have x squared plus y squared is 1 squared. Well, 1 squared is just 1. But notice from what we did previously, we had x equals cosine theta, y equals sine theta, so I can replace x with cosine theta. That's going to be squared. Replace y with sine theta. That's going to be squared. That's going to equal 1. So we can rewrite this again as cosine theta quantity squared is actually cosine squared theta. By the way, if you use a calculator like a TI-83 or something like that, you have to enter it in your calculator like this. It won't take it like this. So that's just a little side note. We're not going to be using that information, that factoid in this video, but that's important to know if you're at this level of mathematics. So this is called a Pythagorean identity. This is one of the most important identities in trigonometry. So like in the AP Calculus class, you need to know this, and there's two others that can be derived very quickly from this, but that's not the purpose of this video. So I'm going to take this property and bring it over here now. So remember, I just wrote, I'll write it up here now. I just wrote that cosine squared theta plus sine squared theta equals 1. So how am I going to use that? Well, this is what I'm going to do. So I'm going to go over here, and notice here I have cosine squared A, here I have sine squared A. Well, together, when you put those together, they make 1. So I'm over here, I'm going to write 1. Okay, then I'm on the left side of the equal sign. So notice then I have cosine squared B and sine squared B. Those also make 1. So I'm going to add another 1 over here. Then I have minus 2 cosine A cosine B plus, I'm sorry, minus 2 sine, that's supposed to be sine A, not a very good looking A, minus 2 sine A sine B. And that's going to equal, on the right side, notice there I've got cosine squared theta plus sine squared theta, that's also 1. So I have minus 2 cosine, minus 2, to try again, minus 2 cosine theta. I have 1 minus 2 cos, I have this 1, but then I have another one right there. Let's just put that in while we're at it. And then I have minus 2 cosine theta. So now let's look at both sides here. Well, I have 2 here and 2 here, so I can subtract those out. So now I'm left with, and notice I have negative 2, negative 2, negative 2. I can divide everything out by negative 2 on both sides. I'm just dividing both sides by negative 2, which you're allowed to do. So that gives me cosine A, cosine B, minus sine A, sine B. But if I'm dividing by negative 2, that should be plus sine A, sine B. And that equals cosine theta. Okay, so now we have cosine theta equals cosine A, cosine B, plus sine A, sine B. But theta, way back at the beginning of this thing, I said is equal to A minus B. So I can now finish my derivation by saying the cosine of the quantity A, or the cosine of A minus B equals cosine A cosine B plus sine A sine B. This property is to be very important in deriving some other properties of the sum and difference of sine and cosine. And this is the end of my presentation. So I hope you found this video informative, and if you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. Again, I said you may share the content of this video with others despite what I said, what I had written in my opening remarks, although I did point out there that you can share it there also. So please, hope this was helpful again, and have a good day.